Hi, this is Alex from devstories.eu. GitHub Actions, episode 12 of 14. GitHub Cloud Runners are extremely convenient until your integration tests need to hit a legacy database securely hidden behind a corporate firewall. Suddenly, a public runner cannot reach your private data. This is exactly where fleet management, hosted versus self-hosted runners, comes in. By default, GitHub Actions use GitHub-hosted runners. When a workflow triggers, GitHub spins up a fresh virtual machine. You can request Ubuntu, Windows, or Mac OS. The runner executes your job, reports the result, and then the virtual machine is immediately destroyed. It is a clean slate every single time. You do not manage the operating system, you do not install security patches, and you do not worry about leftover files from a previous build. However, that isolation is a double-edged sword. Because those runners exist in GitHub Cloud infrastructure, they operate with dynamic IP addresses and have no direct access to your private networks. If you have an internal application or a database that cannot be exposed to the public internet, you need a runner that lives inside your own security perimeter. This is a self-hosted runner. You provide the hardware. It can be a physical server in a data center, a virtual machine in your cloud provider, or a container. You install the GitHub Actions runner application on that machine. The runner connects outward to GitHub, retrieves pending jobs, runs them locally, and sends the logs back. Because it lives on your network, it can talk securely to your internal infrastructure without punching holes through your firewall. Here is the key insight. You own the hardware, which means you own the maintenance. You are responsible for operating system updates, network security, and installing necessary dependencies like language runtimes or build tools. A common misconception is that self-hosted runners behave exactly like the hosted ones. They do not. GitHub-hosted runners are ephemeral by design. Standard self-hosted runners are stateful. When a job finishes on the default self-hosted runner, the machine stays running. If your job writes a temporary file, starts a background process, or pulls a large container image, all of that remains on the disk when the next job starts. This creates serious cross-contamination risks. A faulty build script in one pull request could leave corrupted files behind, causing the deployment job that runs right after to fail. You have to actively configure your self-hosted infrastructure to be ephemeral if that is what you want, often by using webhooks to spin up fresh containers per job. If you simply need more processing power or a static IP address, but still want GitHub to handle the machine maintenance, there's a middle ground called larger runners. These are GitHub-hosted machines where you define the hardware specifications and network features, but they remain ephemeral and managed by GitHub. Ultimately, the decision between hosted and self-hosted is rarely just about compute costs. It's a fundamental trade-off between the convenience of a zero-maintenance, disposable environment and the necessity of controlling your own network boundaries. Thanks for spending a few minutes with me. Until next time, take it easy.